Hello everyone, welcome to another video of Cloud Deep Dive. Today I'm starting a new series on AWS networking. Under this series, I will cover different topics on AWS networking, which will help you to prepare for your AWS certification. I will be publishing a new video every Sunday at 7 p.m. Central Time. So please subscribe to our channel and click on the bell icon to get the latest updates on that so that you don't miss any new video. So let's start with today's topic. Today we will discuss about VPC and subnet. So what is a VPC? VPC is a virtual private network dedicated to your account. It is logically isolated from other virtual networks in the AWS cloud. It also gives you complete control on your network. It allow you to choose your own CIDR range. It will allow you to create your own subnets with different sizes based on your need. It allows you to create and configure how you want to route your traffic, maybe within the subnet or within the VPC or between two different VPCs or maybe with the internet. It also allows you to keep a different architecture completely separate from each other. Suppose you have two different applications and you want to keep them separate and not to talk to each other. So you can define rules and you can set up in such a way that they are isolated from each other. So to understand the VPC more better, let's take an analogy of a city. So in a city, you will have different areas, like you have residential area, you have commercial area, you have military base, you might have a airport zone and a VIP access, you have your government buildings and so on. So to set up that city, you might create different areas. Okay, this area is only for the commercial, where all the shops and other things will be set up. This will be for the residential area, all the houses and everything will be built in this particular area. And you might have a separate area for the VIP, where you are all the VIPs are living, and you might have a tight security there. And then you might have the government offices place, where all the government offices will be situated, and then military base will be separate area. And then you would like to put some kind of controls or some kind of a security there, that who can access these areas. So like if we talk about the military base, only the military people can go there. If we talk about the airport zone area, that only people having the tickets or picking up their friends and families or relatives can go there. VIP area, on the VIP people can go, only people who have access to that area can go. Commercial area can be accessed by anyone. So basically that for each area you have a control, and you also would like to set up a limit that, okay, in my residential zone only these many number of houses can be built. If it exceed more than that, then we have to come up with a separate area where we'll have more houses set up. So maybe you will just kind of plan it out in such a way that city, and you have some spare space in case you need a growth, so you can use that area for your future growth. So VPC is similar to that. You can think of VPC as a city, and subnets are those smaller areas within that city. So you will define, or you define a VPC with a big range, that okay, you come up with a plan. Okay, I might have this much of population in my city, and then my residential area. Suppose you are defining three residential area, and each residential area limiting, okay, it can have these many number of houses. And you also keep something in your mind for future growth, that if it grows, then I might need some spare uh, area where I can grow my city as well. So VPC is like that. You will come up and you will set up a VPC with some number of IPs, and then you will carve out separate subnets, separate areas within that VPC with a smaller range. And if you need more subnet or more resources within the subnet, so you may expand, or you may come up with a new subnet. So that's how you can relate a VPC with a city, and you can try to understand that how they are related with each other. So now as we understand what VPC is, now let's talk about a little bit more about what are its characteristics. So first thing is, VPC spans all the availability zones in a region. So it's a regional service. It cannot span between two regions. It will be restricted to one region, and it will cover all the availability zones within that region. It supports both IPv4 and IPv6 address ranges. So when you create a VPC, you have to provide a CIDR range. It supports both IPv4 and IPv6 address ranges. Next place, when you create a VPC, you have to provide a CIDR range between /16 to /18. anything more than /16, suppose you're going with /15, or uh, more than /28, like /29, will it won't allow you, it will give an error on that. Also, AWS recommend that you use the CIDR break from a private IPv4 address range. So private IPv4 address range is like basically RFS 1980 range, and these are the some of the example like 10.0.0.0 to 10.255.255.2. That's basically /8 prefix. So they say that you choose that IPv4 range from this range, and like I mentioned, it has to be /16 or smaller, or /28 or bigger. Similarly, another range is 170.16 and 192.160. So AWS recommend that you use these ranges while creating the VPC. Now, I talk about the CIDR. So what is the CIDR, and how you can figure out how many IPs it will cover. So I put a slide here. CIDR is basically classless inter-domain routing. So there are two kind of earlier days there was another thing called classful, and it has some limitation, and then they introduced the classless. So I'll cover the classful after this slide. When I go to the demo, I'll show in the wiki that how it is set up and what are classes what involved. But in the classless, basically what you do that you have a IP address. So we all know that IP addresses are built of four different numbers separated by dot, and each number can go from 0 to 255. So basically each number is represented by 8 bits, and the bit can be from 0 to 1, 0 or 1 basically. So if all these bits are 1, that means 2 to the power of 8, that means the maximum value can be 255, and if all are 0 is 0. So the range of one block within this IP is 0 to 255. So CIDR representation is basically your IP address slash a number. That number talks about suppose I'm giving is 16, so that talks about that how many bits in this IP range are masked. So if we say that 16, so each number is 8 bit. So first 16 bits are masked. So whatever value is in there, it won't change in that range, and whatever the next two uh, fields are there, next two bytes are there, the 8 bits, these value will go from 00 to 11111. So in this particular CIDR range, you can say the minimum IP address will be, because these two fields will be constant, so 170.16, and these two bytes will vary. That means it will be 0.0 to maximum can be 1111111, so it will be 255.55. So with a /16, you can get maximum of 65,536 IP addresses. And to calculate how I got this number, suppose you have a CIDR block of 172.16.0.0/24. So how you get to know that how many IP addresses this range will provide? So the calculation you can do it is, because we have 32 bits in a IP address, 8 plus 8 plus 8 plus 8, 32, minus how many we are masking. We are masking 24, because whatever number we are providing here, that means those 3 bytes or those bits will be masked. So if I'm saying 17, so 16 plus 17 till here will be masked, and rest of them will be used to get your IP address. So in this case, I'm masking the first 3 bytes, 24 bits. So 32 minus 24 is to the power of 8, which will give you 256 IP addresses. Similarly, if I go with the 25, that means this one, this one, this one, all 3 bytes are masked, and this particular bit is also masked. So only these 7 bits will contribute towards calculating your IP range. So you will get 128 and so on. So that's how you can calculate the IP addresses. Next, let's go to the AWS console and we'll see how you can create a VPC and a subnet. So guys, we just discussed about the classless inter-domain routing, which we call CIDR. Now, that was introduced in 1983, but prior to that, we had classful network, and in that, basically what they did, that they divided addressing in 5 different classes: A, B, C, D, and E. D was used for the multicast, and E was reserved. So basically, there were 3 classes which you could have used to define your network. And in class A, what they did, that first leading bit was 0, so leaving only 7 bits which you can use to create your network, and the remaining 3 bytes were used for your hoster. That means that you can create these many addresses per class for the class A. Similarly, for the class B, your first 2 bytes were masked and leading bits were 1 and 0, leaving only 14 bits for your network. So that means you could have created these many networks. Like in this, you could have created only 128 networks, but in this case, you can create these many networks, and addresses in the particular network, these many IPs or these many IPs you can create. Similarly, for the class C, your first 3 bytes were masked and the first 3 bits were 110, leaving you these many networks you can create, but per network you can have only 256 of IP addresses. Here they have given an example as well. So for the class A, the first bit, this bit will always be 0, and these bits, 7 bits, will contribute you to a network. So these will be the network bits. So that means that how many networks you can define. So with the 7 bits, you can define 127 networks, and with the remaining 3 bytes, these are the hosts, these are the range you can define within that network. Similarly, for the class B, your first bit will be 1, first 2 bits will 1 and 0. So remaining these 14 bits, 6 plus 8, these many network you can define, and within that network, these many IP addresses based on 2 to the power of 16, these many IP addresses you can create. For the class C, the first 3 bytes were constant 110, and the remaining 8, it's 16 plus 21. So 21 network to the power 21. These many networks you can define, but within each network you can have only addresses of 256 because only this one was your host bit. So that's how the class A, B, and C used to work, but there was a limitation. Suppose like you can see, the class C can give you only 256 IP addresses within a network, and if you need 2000 IP address within a network, then you will have to go with the class B. But the class B bare minimum will give you 65,536 IP addresses. So 45,536 will be wasted even though you don't need it. So to overcome this issue, they come up with the classless interdomain, because in this you can define your own range. You can have because with the CIDR block we discussed, you can give a, suppose you give 127.258.0.0/12. If we give the 12, oh sorry, 20, if we give the 20, that means the first 8 and the 4, these many bytes will be masked, and you will get the IP range of these many bits, which will be more than 256, right? So based on your need, you can define the CIDR range, and based on how many IP addresses you need. So going to the console, let's see how you can create the VPC. You go to the services and you will go to network and content delivery, and under that you will find VPC. So Amazon will, whenever you create a new account, so in each region, one VPC will be created by default for you. So you don't need to create that. But if you need more VPC, or you want some granular control, or you want to run, so you can create your own VPC. So for that, we'll go to your VPC and we click on create VPC. We'll give some name, so demo VPC, and so here you can see the VP4 CIDR block. If you click on the info, you can see that the CIDR block must be between /16 and /18 net mask, so it cannot be /15 or it cannot be /29. So if you do 10.0.0.0/15, and if you try to create with that, it will give you an error. So we have to create with the /16. So let's create that. Next, you can define, if you want, you can have a IPv6. So you can, if you have any IPv6 pool and you have kind of imported it in your account, you can use that, or you can use one provided by Amazon as well. So in that you have it will check that which, because I'm in Oregon region, so it's selecting that particular region. So I don't want to do it with IPv6. Next, with the tenancy. Tenancy is basically default or dedicated. Default means we have two kind of tenancy. One is shared, one is dedicated. Dedicated means all the EC2 instances launched by you and your account will be launched on a dedicated hardware. No other EC2 instance from any other account or from any other company will be launched on that host. So only your account EC2 instances will be launched on that hardware. But in case of shared, you will get a shared host underline, and EC2 instance, it can host any EC2 instance from a different account or from a different organization. So based on your need, you can choose default or dedicated. And then if you want, you can provide some tags here, and then you can click on create VPC. So when you create a VPC, some of the components will be created by default. So one thing is route table will be created by default. So if you see my new VPC, which I just created, MOC is ending with 8VE. So I got a route table created by default for the VPC 8VE. Another thing should be NACL. So you can see that one network access control list is created by default. So another thing is one security group will be created by default for you. So these are the few components which will be created by default for you whenever you create a new VPC. Okay guys, now let's see what we can do with the VPC. One thing, if you go to actions, we can perform all these actions to it. A few of them will talk in later lectures, but the one thing, you can delete the VPC and you can manage your tags. The next thing, you can edit the CIDR. So right now, like we have only this CIDR. If you want, you can add a new CIDR prompt. Suppose you want to expand the range of your VPC from whatever the number of IP you have defined is getting small, or you need more, so you can add more IP addresses by adding a new CIDR. And if you want, you can add a new IP6 CIDR as well. Next, let's see how we can create a subnet. So subnet, like we mentioned in our analogy, is kind of small area within your VPC. So it will be a small block within your VPC having some IP address assigned to it. So let's see how we can create it. So we select a VPC ID. It will give you the CIDR range for that VPC. Now we give the subnet name. Suppose we say subnet 1. Then you have to provide in which availability zone you want to create it. If you don't provide that information, so AWS will pick any availability zone on its own. And one thing to remember with that all these subnets, they cannot span in multiple subnets. They will be dedicated, or they will be defined only in a particular subnet. And you can have multiple subnets within availability zone. You can have that, but you cannot have one subnet spanning between two availability zones. So let's see, we gave a availability zone of 2A. Then we have to provide a range here. So I'll give it /24 so that I can get 255 256 addresses. I can add tags. We can add one more subnet here. So we'll add subnet 2, and I'll define it into 2P, and I'll give the range as, okay, so I got to 56 addresses here. So basically with the VPC CIDR range, we got 65,436. I guess these many IP addresses. Out of that, I used 256 for the first and 256 for the second subnet. And if you want, we can add more subnets to it. So let's do create subnet. Okay, so one thing you will notice that when subnets are created in the VPC, it will show you only 251 IP addresses are available, and that's because AWS reserved 5 of the IP addresses. If you check AWS website and their documentation for the VPC, it's clearly mentioned under VPC and subnets that first 4 IP addresses and the last IP address of each subnet CIDR block are not available for you to use and cannot be assigned for any to any instance. So they will reserve first 4. So in our case, like we had 10.0.1.0 and 10.0.2.0 for each of the corresponding subnet. The first IP address will be network address. The next one .1, in networking we call it .1. It will be reserved for your VPC router. .2 will be reserved for your DNS server. .3 will be reserved for future use. It's not assigned to anything or not doing anything, but they have reserved it so that in case something else some need comes in the future, they can use it. And dot 255 we use is your network broadcast address. So it does not support in VPC, but yeah, they reserve it for that. So that's how these five addresses are reserved and being used, and they are reserved for each subnet you create. So whenever you are creating, suppose you need 256 IP addresses in subnet, then you have to go with /23 so that you can get 512 IP addresses, and after that 5 will be reserved. So just keep in mind whenever you're doing a subnetting or defining a subnet, how many IP addresses you need. You have to remove 5 of them uh, uh, you make sure that you remove 5 of them because it's reserved by your AWS account. Next, let's see in the edit options what all we get it here. Uh, you can look at the details of that. You can delete your subnet. You can share your subnet with somebody else. You can route it between your you can associate your subnet with the route table and ACL. That will covered in future lectures. Next thing is you can modify your auto assign IP settings. So what is that? By default, whenever you create a subnet, it does not assign any public IP address to your any of the resource you define or you launch in the particular subnet. What does that mean? That if you launch EC2 instance in the subnet, it won't get a public IP address. So you have to go and explicitly add or enable this setting, enable auto assign public IP4 address. And once you save it, now whenever you launch any EC2 instance in the subnet, it will get an IP address. So just keep that in mind whenever you're defining creating an EC2 instance, a newly created VPC, and if it does not get an IP address, then make sure that you come here and enable it and then relaunch it. So guys, we learned in this lecture about VPC and subnet. So in our AWS cloud, we in a particular region, US West 2, we create a VPC and we created two subnets. And we learned what is a VPC and what is a subnet and how you can create these two. In the next lecture, we'll talk about route table and the router and internet gateway and how you can make a particular subnet as private and public. And that will come next Sunday, 7 p.m. Central Time. So please subscribe to my channel and press on the bell icon so that you can get the latest update when the new video is launched. Till then, thank you so much guys. Have a nice day. Goodbye.